Welcome back to Multithreading internal series. In the previous video, we looked into basics of thread and process. What exactly is thread, what constitutes a thread, and how it behaves inside a process. So we took the examples of two Java programs. One was single threaded and another was multi-threaded, and how it behaves in JVM process. In this video, we will look into multi-threading at operating system levels. We will look into three topics: context switch, thread scheduling, threads versus processes. So coming to context switch, for example, we have a CPU, we have CPU, one CPU and a process running in our machine, and there are in this process P1 we have two threads T1 and T2 and operating system running. So operating system schedules the threads on the CPU. It assigns the time slices to the threads which executes on the CPU. So at any given point of time, one thread runs on CPU. So if operating system assigns some time to T1, and when it's time to assign the time to T2, so T1 has to go and T2 has to take its time slice. So in this scenario, thread T1 is status is restored, and the status of thread T1 is stored, and the status of thread T2 is restored, and it consumes its times on the CPU. So thread T2 will take its time on CPU and executes the executes the instructions. So here the switch has taken the thread T1 went into a stored status, and T2 has restored and took its time on CPU. This act is context switch. So if we have multiple cores, then operating system automatically, for example, in this machine we have multiple cores, so operating system schedules all these threads on CPU, and if the switch is between the threads belonging to single process, then the status of threads are stored and restored. And if the switch is between processes, like for example now T2 is running on CPU on this CPU, and operating system, if it schedules T3 on the same CPU, then the whole process status need to be stored, and status of the process P2 need to be restored along with thread T3. So this is a costlier switch compared to the switch between two threads inside one process to the threads between the two different processes. And let's move on to next topic, thread scheduling. So OS is responsible for scheduling the threads on CPU. For example, if we have music player, text editor, and file saver, so operating system schedules these threads on the CPU and assigns the time for each thread on CPU. And now the question comes, who runs first? Then let's try to understand the strategy, strategies what operating system uses internally. So if you go with the FCFS, first come first serve basis, then if a task comes and if it is a long running task, and after that there are more tasks which are smaller compared to the first arrived task, then the tasks which arrived later, they might starve. So with the strategy of FCFS, we might have the starvation issue. And if we go with the shorter job first, then in this scenario, if the shorter job takes the time of the CPU, and the other shorter jobs arrive frequently, then all the shorter jobs will get the time on CPU, and the longer running jobs, they will starve. So this strategy also doesn't work. So what exactly internally OS uses is Epoch. So Epoch is a time window which is configured in operating system. So here we have epochs E1, E2, E3, E4, and for example, if we have these tasks T1, T2, T3, and T4, what operating system does, right? It assigns each task time. For example, if it assigns 50 milliseconds to this task, and then it assigns 100 milliseconds to the next task, and it can assign 30 milliseconds to another task T3, and if it assigns 40 milliseconds to the task 4. So these all processes run in one epoch. So everyone will get the chance to run on CPU. So this is the strategy used by operating systems. So we have one question now: when to go with the multi-thread process versus multi-process application. So if the like I would see it's similar to monolith versus microservices in the distributed system. So if we have tasks which are related to each other, it's better going we should go with multi-threaded, so they should be part of one process. And if the tasks are not related and they can be executed independently, and if they don't depend on each other, then we can go with the multi-process strategy. So with this we will end this video, and in the future videos we will go into more topics of multi-threading internals.